Hey all, I guess we can start. Hey, I'm Giota Eftaxiz, lead platform engineer in Allwyn Lottery Solutions. And today I'm going to walk you through our migration journey from our legacy platform to our own Kubernetes platform that we call Athena. So we're going to start on where did we start from, what was the legacy platform, what is Athena platform, why we decided to build it. Then we're going to see a bit of our day-to-day and how we work. And last but not least, how we are currently improving the platform. Where did we start from? So our legacy platform was based on a separate VMs architecture. Each VM was hosting a single application instance. There were a couple of limitations in this architecture. First of all, it restricted engineering teams for adding new services easily. Resources were not efficiently allocated across virtual machines. That was true both on cloud and on-premise workloads. To give you an example, we required 7 EC2 instances just to host a single AWS development environment. Our patching and infrastructure component upgrades were not trivial tasks, and cloud and on-premise environments followed very different deployment ways. That was true both for infrastructure and application deployments. What is Athena platform now? Athena is Allwyn's standard Kubernetes platform for running lottery application services in production. It provides a consistent production-ready environment with standard operating practices. Athena is not just Kubernetes, it includes all the operational services, tooling, and governance required to run customer-facing workloads at scale. Again, both on-premise and on cloud environments. What does it offer now? It is offering self-service deployment and management. It offers standardized workloads that reduce deployment time, uniform infrastructure and policy enforcement across environment, and last but not least, active scalability for high availability and uptime. Now, as you see, the landscape is rich, but we will focus on a specific part of the platform. To give you some technologies we are using Packer to build our base images. Then we use Terraform to deploy our infrastructure. And then we use Kubespray, which is a collection of Ansible playbooks that deploy Kubernetes on top of our infrastructure. And also Helm to deploy both infrastructure and application Helm charts. And all the above are deployed through custom GitHub actions we provide to the teams. Now, why we decided to build our own platform? The basic requirement for us is that we needed a platform that runs consistently across both cloud and on-premise environments. So our customers, either they are internal or external, get exactly the same operating model and controls. Athena uses a single Kubernetes distribution and lifecycle workflow across AWS and on-premise. Now, was it a good idea? The benefits, let's say, of this approach was it is consistent, and that reduces operational overhead for us because it keeps development and production behavior aligned. And that gives us higher confidence during changes and upgrades because we have tested most of the changes in previous clusters. And since we use self-managed Kubernetes, we gain as a team more experience in managing Kubernetes cluster. And last but not least, we have reduced operational cost because we have no licensing cost. The challenge is actually handling your own Kubernetes cluster and especially Kubernetes control plane. And let's say another challenge we face is that the platform upgrades need more effort from the team because you have to ensure that they run smooth. And especially when we start the upgrade process, the first clusters we upgrade, we tend to find more issues. As the process goes on, it gets smoother and smoother. I mentioned upgrades. What about Athena upgrades? Athena follows a planned upgrade process. We do platform upgrades every 4 months. They include the underlying OS, which is, in our case, is ROC Enterprise Linux, Kubernetes on top, and all the services, the core services we deploy. Also, if in that period of 4 months we have any new features introduced, they are part of the upgrade also. We usually deploy 1 or 2 versions before the latest Kubernetes version, just to ensure we have a stable version of Kubernetes. And we deliver upgrades as a rebuild. That means that platform engineering team reprovisions infrastructure and clusters from code. That approach treats the platform as immutable and avoids in-place patching of long-lived nodes. The benefits now of this model, we have predictable outcomes. We apply changes from clean and known baselines, reduce drift because Git is our source of truth for the cluster state, faster rollback because for us rollback is just deploying the previous version of the platform, and it helps us strengthen our security posture because the platform retires old nodes rather than patching them in place. Now, there are areas of improvement in that approach because in the best case scenario, the whole upgrade process takes around 3 hours for each cluster. And although in production we do this without any downtime, in pre-production, when we upgrade the platform, it means that we have service and availability. And again, Kubespray is time-consuming. For a 20-cluster node, it takes around 50 minutes. Now, what GitOps looks like in our day-to-day, let's take the platform upgrade example. We have the platform engineer that will create a PR that will bump the image version. On that PR, once the PR is opened, it will trigger a Terraform workflow that under the hood will run a Terraform plan and show the changes that will happen, and it will be applied on merged. Now that we have, in the specific example where we bump the image, it will mean that it will destroy and recreate from scratch the VMs. Once that is done, we will trigger the Kubespray workflow with the updated Kubernetes version, and we will run that also as a GitHub action. Then, once that is finished, we trigger the Helm workflow, which for us deploys all the application and infrastructure Helm charts. The interesting thing here is that our engineering teams use the exact same Helm workflow I mentioned. Let's give a day-to-day example. A developer wants to bump the replicas of their application in a specific environment. What they will do is they will open a PR, they will bump the replica count, and once they merge, they will trigger the Helm workflow, and that will apply their change and bump the replica count in the specific environment, in the specific cluster they select. Now on improvements. Although we're running with this platform in production, I think it's around 3 years now, and it is quite smooth. We didn't have any major incidents so far. There are things we want to improve as we go. One challenge we faced is that we have code duplication around Helm charts repository. A common best practice, let's say, to resolve that is to use Helm common libraries. What they provide is they provide reusable templates that other application charts can inherit. The benefits of this approach is that now we have unified charts. It reduces code duplication because we're using the do not repeat yourself principle. It consists of shared resource templates found in most charts. It serves for us as a reference when we create new charts, and it defines the standard default values as best practices. Another challenge we faced is that we use Helm secrets with SOAP's encryption to store our secrets, and that prevented us from easily rotating secrets and from migrating to Argo CD, which is something I'm going to mention next. For that, we introduced external secrets operator. This is an operator that reads information from APIs of external secret management tools and automatically injects the values into Kubernetes secrets. First, the first benefit for us was that it was compatible with Argo CD, this approach. It reduces a lot attack surface because secrets are no longer stored in code. It enables auto-rotation of secrets without need to do any code changes. And it gives us the opportunity to have more granular secret ownership than we could before. Now, another challenge is, I mentioned that the custom Helm GitHub action we use, and this caused a bit of long and error-prone application deployment for us. And we were lacking also a UI for operations and development teams. We introduced Argo CD for this, which is a Kubernetes controller which continuously monitors running applications and compares the current live state against the desired state of the cluster. The benefits now of this approach is that it gives us zero-touch application deployments, full visibility to the cluster without need to do any kubectl commands, easy monitoring of configuration drifts across environments, instant rollbacks when things go wrong, simplified troubleshooting and debugging of our application, and in general, improved the development experience on day-to-day operations. Now, would we recommend it to a friend? Yes, but if they want to one operating model across cloud and on-premise, and they are happy to earn it. Thank you, and if any questions.